Hey, hello everybody, welcome to the first event in the Encode X Fuel Educate series. Like you probably already know, this is a two-week education series focusing on the Fuel network, which we'll be covering a lot of very cool topics regarding Fuel network, like its architecture, like the Fuel VM. We'll be doing some indexing as well, and all of this will be happening over the next 10 or so days across 6 different sessions. For those of you who don't know me, my name is Nevin. I'm an operations manager at Encode Club. And very quickly, I just want to introduce our company. We are an emerging tech education community, which basically means that we organize different kinds of educational programs. Like this particular event is a part of the Educate series, which are basically just educational workshops. But we also do hackathons, we also do accelerators, boot camps, and finally we also do recruitment for Web3 and AI companies. A little bit about the education series itself. Today we're kicking off with a workshop by Nick Dodson from Fuel Labs. We'll be talking about the introduction to Fuel and modular blockchain architecture. Then tomorrow, Laisha Wadva from Fuel Labs as well will be talking about deploying native NFT collections on Fuel. After that, we're going to mix things up a little bit with a couple of guest speakers. Firstly, Dimitri from Envio will be talking about data indexing with Fuel. And then next week on Monday, we're continuing with Envio as well with a presentation from Joss. Who will be covering fast historic data querying with Hyperfuel. For session number 5 next Wednesday, so that's in 8 days, we're going back to the Fuel Labs people with the wonderful speaker David, who will be talking about predicates. And finally, we're going to close the whole series on Friday, the 26th of July. So that's next week with a workshop from Lydia Zaba from Coin Possibility Labs, who is going to talk about the building stateless DeFi applications. Finally, a reminder that you should join our Discord server if you're not there already, because that's where all the primary communication will be taking place in terms of all of the updates regarding the series, and where all of the workshop recordings will be posted the day after the workshop itself happens. And finally, just note that this whole educational series is just a prelude to the hackathon with Fuel, which will be kicking off on the 30th of July, so right after we close the education series. And I don't want to dwell on any of this longer. You can find all of this piece of information on our website as well. Now I'd like to invite Nick from Fuel Labs to the stage for the first workshop. So Nick is getting ready. He should be here in a second. And there we go. Nick, hi. Let's say hi to the people. And yeah, feel free to kick it off whenever you are ready.
Hey everyone. Thanks for joining. I hope everyone enjoys the IKEA stock art that's behind me. I think this is something that it's kind of a masterpiece, as you can see. It's a background of Paris. So just, wanted to highlight that as we get into this. It was not chosen by me. I wish it was, but it just came in the hotel room. So let's switch over to presentation. We can go from there. So I think it should be this one. Okay. Can you guys see my screen? The Fuel 101
yes,
primer?
That's perfect.
Excellent. All right. So so for this presentation, I'm going to try to not go too deep, but unfortunately with Fuel, as you might learn, we go too deep way too quickly all the time. And one of the key things about Fuel is it's very hard to explain Fuel. So we will try today to go over as much as we can, but as well, I'll try to show everybody what resources are available, both forums, docs, other things that we're doing, and just try to show you how we're thinking about everything with Fuel, so that people can get a good sense of kind of where we're at and where we're going, and why Fuel needs to exist in the first place and why it's important. So cool. So let's get it off, kick it off. So the first thing I thought I'd address is why the name Fuel? Because this is something that maybe you don't think about when you deal with some of these projects, but why Fuel? Why is it called that? Well, the answer is pretty simple. It's just because we use the term gas all the time for Ethereum and for many other blockchains. And so it kind of made sense to call the project something in relation to that. Fuel's whole job is to reduce and then eventually and hopefully get rid of gas altogether, and try to make blockchain as efficient and as how you could say sustainable and accessible as possible for the entire world. So Fuel just felt like the right name at the time, and obviously there's a lot of good memes you could build around the name Fuel. So that's just a starting point. Why the name Fuel? It's just a simple name for gas. So to start off where the Fuel project started, we deployed the very first optimistic rollup to Ethereum mainnet way back in December 2020. So at that time, it was a small team, just 3 people. We did manage to build an optimistic rollup that not only was one of the first, but actually fulfilled a certain set of security criteria that still today most rollups, or if not all rollups, do not fulfill, which is really to say that we wanted to build an extension to Ethereum. So we wanted to have Ethereum as our sort of base layer, and then we provide this new form of execution on top. And you really do inherit all the security properties of Ethereum, the decentralization, the amount of validators, the amount of cryptoeconomic security. And you do this by having things like having fully working fraud proofs, not having an upgrade multisig, really providing a way for people to always exit back to Ethereum. So all these different pies were fulfilled. And still to this day, if you go to the layer 2 beat and you scroll all the way down, you'll still see good old Fuel v1 as basically one of the first and real and only optimistic rollups ever. So it's kind of unfortunate for me to be, you're unfortunately listening to maybe the only person who's actually built an entire optimistic rollup. It's a little sad, but at the same time, it's also, Fuel v1 was very simple. It just did payments. It just did transfers and swaps. So it's not to say that like these other rollups, in due course, they'll fully achieve these pies. But it's just to say that, it was a simple rollup, but it kind of proved a point that you can do this and it is possible. And we should aim for that with all the optimistic rollups or all the different rollups that are going live on Ethereum. So that's like the very humble beginnings of Fuel v1 and Fuel itself. So we started Fuel in the middle of 2019, and we finished Fuel v1 about a year later after really working on things in like December 2020. So what is Fuel? So Fuel itself is an architecture. So you can think of it as a suite of tools, standards, and specifications for developing sustainable high-performance layer 2 rollups. And we sometimes refer to it as like a rollup operating system. And to get into this sort of suite of tools, we have our own execution client called Fuel Core. We have our own tool chain called Fork. We have our own sequencer and sequencer client. We have our own language called Sway. We have our own explorers. We have our own wallets. And as well, we have like a set of SDKs. And in terms of the standards, we have our own transaction architecture. We have our own virtual machine architecture. We have our own form of application binary interfaces, APIs. As well, we also have, again, our own sort of language specification. And then we have our own language and application standards called Sway standards. So it's really a giant suite of tools. And by the way, there's actually a lot more stuff that we're building that's not even here yet, such as like how data and indexing will work, how all kinds of different application constructions will work. So you're seeing sort of just the tip of the iceberg for the amount of stuff that we're actually building. But effectively, the idea is that this is a whole new architecture for building blockchains, particularly rollups, and building blockchain applications, and blockchain applications that can really be accessible to the entire world, that you can create your own blockchains around, you can create your own rollups around, and that hopefully, if you were to achieve the very lucky goal of actually having, say, more than 20,000 or 100,000 users, that the architecture would scale with you and wouldn't cost you very much. So why fuel? Why did we even build any of this at all? Why didn't we just say, okay, let's just copy some existing stuff out there? Why do any of this at all? Well, it starts with this fundamental idea, I guess, that when you look around at a space, and your space that you've been in for many years, I've been building in blockchain since 2013. I've been working with Ethereum since like 2015. When you take a look around and you realize that everyone's copying everything, and that no one's actually trying something really different, you start to kind of wake up to the fact that maybe you should actually just try something different. And so I kind of say with Fuel, like the entirety of Fuel and what we're doing is not copy pasta. So we designed everything for Fuel from first principles, not because we wanted to get users or distribution, but because we thought it was the right thing to do. So we didn't go pick EVM or WASM or Move or Solana VM or whatever. We didn't use those architectures because all of them didn't really answer all of our questions, and all of them had particularly different faults and issues that we just felt like if we're going to actually go and do something different with rollups and do something different on the execution side for Ethereum, we want to be a project that tries something different, and we do our own kind of thing to really solve problems from first principles. And so when you look at what everyone else was thinking and what everyone else was doing, we'd often hear the same kinds of things, which is just like, well, why don't you guys just use the EVM? Like, it's good enough. Like, everyone's hooked up to it. Solidity works for it, or just use WASM. Like, then you can use Rust and TypeScript and people can target it. Or, RISC-V, like, I hear that's good. I hear that's simple. Or why don't you just support, Solidity? Like, it's not great, but it works. Or, hey, just use the Move architecture, or the Solana virtual machine architecture, or like it's used by these other communities. Like you can use it, and then you're going to get those dApps can then deploy to you, right? And with Fuel, we just didn't listen to any of that, because for us, we understood the trade-offs of all these architectures after both researching and using them for some time. And we felt like we needed to build something more holistic that solved a lot of different issues at once, because it's kind of the nature of the way blockchains work. And so with Fuel, we wanted to build and design something from scratch that holistically solved the problems of modern blockchains. And particularly, we didn't listen to business people. So business people would have told you, just use an architecture that people can copy and paste and put things on, and then you'll get projects and you'll get users, and then it's all good. You don't need to think about it. Business people would not understand that, like, well, do you understand the pitfalls of the EVM? Do you understand why it doesn't scale very well? Do you understand the pitfalls of Move, or the pitfalls of Solana, or the pitfalls of these other architectures? Like, do you have any context on that? Are you just making that decision just to get distribution? And typically that's the case. And so with Fuel, we made the very hard, awful life decision to not do the distribution route and to really try to build something really holistically different that solves these problems. So in terms of what does Fuel offer, and also similarly, what does it solve? Fuel's architecture solves for many things at once. A big one, which you probably heard for some architectures, is parallel transaction execution, as well state minimization, interoperability, native account abstraction, a low-level virtual machine, and as well flexible development. So these are all kind of the topics that I think do come up, at least more in the research circles, about things you want from your blockchain architecture. So in terms of parallel transaction execution, Fuel can be processed and transactions can be processed in a highly parallel way, such that not only can we process and verify blocks across a large set of blocks, which is pretty interesting. So it's not just verifying one block, but many. But we also can verify, execute, and process transactions from within a transaction. So we actually have sort of like little tiny programs inside of a transaction. All of those can be run in parallel as well. And so this massive parallelism gives us a huge advantage, because it means that we can get ahead of processing really significantly. And we're trying to bring blockchains into a place where we have a lot of different transactions to either verify or execute. And you want to get those programs into a place where you can actually get ahead of all that processing. And that goes for not only just the traditional sort of optimistic verification, it also goes for ZK verification. So if we were to deploy a Fuel ZK tomorrow, one thing you would really want is to be able to get ahead of all the different kinds of proving that you need to do, right? So you would want to be able to break up the program to many small programs anyway to get ahead of proving. Similarly, with verifying and syncing, you want to be able to verify and sync a lot of blocks and a lot of transactions really quickly, in a highly parallel way. So our parallel transaction execution is really effective at doing this, not only from a sort of an optimistic standpoint, but also from a zero knowledge standpoint. State minimization is also another big one, which is when you build high performance blockchains and you're running blocks at say 1 second or less, and you're incurring, there's an enormous amount of transactions, say 3,000-4,000 transactions per second or something like that. If you're doing that kind of volume, it incurs an enormous amount of what we call state on the nodes themselves. So it's all the different information you need to either verify the chain or to produce new blocks and to produce new state transitions. And so state bloat is like a really, really big problem. And so we wanted an architecture that was very, very state minimized and that actually had holistic solves to this. And this is actually one of the reasons why we didn't use Move or Solana, is because they didn't really answer this question. They didn't really care. They just thought like, well, we'll just run it really hot and we'll solve this later. Well, you'll notice a pattern with blockchain design, which is that everyone says they're going to solve it later and no one actually does. And then, they'll get wealthy off of some token or something else, and then they don't actually solve the problems. So basically, we wanted to really holistically solve this from the beginning because this is a real problem for sustainable design. Interoperability is another one. We wanted users to be able to come to Fuel apps and use the existing wallets they have, existing assets they have, bridge their assets from Ethereum over. So for a user on Ethereum, it shouldn't feel very different at all to use a Fuel app, other than it's a really great experience. But for a dev, they get all these new tools and ways to build applications that are like far more scalable. Native account abstraction is also very important. You want to be able to support very complex forms of accounts, very complex forms of different styles of accounts and things like that. And so native account abstraction is something you want baked in from the beginning. As well, low-level VM, so something that you could take and you could do just-in-time compiling or other things, and you can bring it right down almost to machine code. You want a VM that has the right properties in mind. So we wanted a VM that's also very, very fast and very performant, and also removes all these edge cases from the EVM. So the EVM has a ton of edge cases as to how it actually works. And we try to solve those with tooling and stuff, but we wanted a VM that was clean slate, that we solved all these edge cases for every opcode so that you don't run into any of these issues. And then as well, a flexible development environment. So we wanted a language and a tool chain that, felt very much like Rust, but with a lot of the nice things that Solidity and other blockchain tooling and languages brought to the table. So what does that all mean? Well, it just means that on the performance and efficiency side, Fuel can handle a lot of transactions at scale while keeping the prices low, which is very important. It's also really cheaper. It's a lot cheaper for users. Things like, state bloat is controlled so that node requirements to verify the chain don't get out of hand. And then as well, it's more interoperable. So you can use any wallet or any asset. Native account abstraction enable things like, fee payer flows, right? So you don't need to use ETH for gas, and, you could use passkeys or Solana wallets or Cosmos wallets or ZK accounts, or whatever you want. And then lastly, flexible development just means, hey, I get a better Solidity and Foundry, so it covers a lot of these different areas. So this is just like a TLDR as to what all that meant, right? So to get into like Fuel and our transaction model a little bit. So Fuel, unlike a lot of blockchains out there that use what we call an accounts model, Fuel uses what's called a UTXO model, so an unspent transaction output model. And UTXOs are nice because they define what areas of the system a transaction is going to touch, such that then the nodes or block builders can kind of get ahead of, okay, these transactions are going to go touch this area of the database and the system over here. These transactions are going to go touch this area of the system or database over here. And so we can organize that and we can kind of parallel process that. And so when you have a transaction that has inputs and outputs, you're defining these are the areas it's going to touch. these are the results, right? The things that's going to change. And as well, we brought over from Bitcoin what we call a similar thing to what's called pay-to-script hashes. And these are, the technical term we use is called predicates, but you can think of them as just spending conditions. And predicates are really interesting because basically they allow you to constrain a way a coin is spent and constrain a way that the transaction is going to work. And when you have this, it allows you to build very sophisticated kinds of transactions. And as we've learned with Fuel over a lot of research, while we do support Ethereum style smart contracts, so you can build whatever you like that's very similar to Ethereum, and we do support scripts like what you would see in something like Move, we also support these predicates. And as it turns out, with just coins and just predicates, what you'll learn is that we can actually build any kind of program, or almost any kind of program, and do it in a way where there's really no smart contracts involved. And so you'll learn of that as we go here. But the main idea is that Fuel is pretty flexible and supportive in terms of its transaction architecture. So right now we'll just get into that. So again, you can have a transaction that can have many coins, and these coins are actually what we call native assets. So the system allows for not only ETH to be used as the main native asset, which you see in like Ethereum, but every smart contract can create its own native asset, its own kind of color, its own kind of coin. And those can be used at the native transaction level. So instead of just having, assets be basically like just ETH as the base asset, and then you have to build application level contracts to, basically create tokens and other things. We actually have this native asset system. So contracts can mint and burn coins. Those coins can come out of smart contract state, and they can be used within the system itself. And this is a much nicer model, because a lot of what blockchains do is just moving assets around, and moving assets around under certain conditions. And so really, when you have this support for this native asset system, it really gives you a significant edge over existing blockchain architectures that don't have really rich native asset support. And similarly with smart contracts, we also allow you to provide one or many smart contracts in execution. And this just means that a single transaction can touch one or many smart contracts. It can touch one or many coins under certain conditions and produce certain outputs. And so it's a very flexible transaction model. And we want to allow the developer to build transactions for their users that do a lot at the transaction level, so that we don't even need to get into smart contracts. And I'll explain why later on. But when we're talking about scripts, we're just talking about, there's sort of this ephemeral logic. So once the script is processed, the full node, right, that validates all the transactions, doesn't need to store it. So it can just prune it and get rid of it. And it's not stored in state. So a lot of what Fuel does is to try to get rid of things off of state, and to get rid of things off of the full node hard drive itself. You don't want to store a lot of things on that hard drive, because if you do, hard drives are very limited in terms of their read-write access and their speed to a computer. While CPUs and memory have gotten a lot faster, the hard drive of a computer is very slow. And so a lot of Fuel is designed to make sure that the full nodes are not accessing a lot of drive, and to try to sort of bring things over the internet, over bandwidth, over Wi-Fi, whatever it might be, and bring the code over that way versus bringing it off the drive, because the drive is very, very limited in terms of the amount of speed it can produce. And so this is like a big piece of what Fuel is really about. And so scripts are just this sort of like ephemeral logic. It's executed once. It does a bunch of things with smart contracts, and it leaves. Similarly with native assets, basically all native assets here only touch a single state element in the system. So each native asset is only one write on the drive itself. And what's cool about that is it basically means that native assets, they use a lot less space on the full node to represent a certain amount of token to a certain owner. And this just gives, again, developers a lot more tools to build application systems and assets for their users that just touch very little in the actual node itself. So when you build a token in ERC20 on Ethereum, What you don't see is, yes, you're writing a state element that says like, okay, here's the balance of this token for this user, and we're going to move it over to this user. That's what you see as a dev. But on the full node side, you have to Merkleize that whole state. And that is really, really heavy. And you have to create this giant Merkle tree. And then that needs to affect another Merkle tree every time you change any of those state elements in a smart contract. And when you do that kind of thing, it ends up being really, really heavy in state and amplifies the amount of state. And again, that means all these new elements and things you need to change in a drive. And it just lays out a whole bunch of random scaling issues that are unfortunate and basically you want to avoid at all costs. And again, similarly with predicates, these are stateless code. So, we are focusing on state here a lot. So the main thing is that you can create things like native account abstraction with predicates. You can create stateless DeFi, order books. You can create Uniswap. You can create a bunch of things. And you're creating it without really touching the drive very much at all. You're just loading up maybe the assets, and that's it. And what's really cool about native assets and UTXOs is that the full node only needs to store per asset a single 32-byte hash and maybe a pointer to what block it existed in. And that's it. So full nodes need to store very, very little in terms of the amount of information that's necessary to progress the blockchain forward. And again, if you want to build applications that really can scale to the entire planet, you have to start thinking in these kind of frames, because you're going to be drive limited, you're going to be limited on a bunch of other factors, and you want to reduce the amount of drive access that you need in order to process and validate transactions. So coming back to the transaction model here, so transactions can have native assets or contracts. Contracts are also inputs, right, in our system, and contracts also produce a specific kind of output. Assets can be sent with spending conditions, and these can be used for things like account abstraction. They can be used to create order books. They can be used to create any form of application, really. And transactions can have things like scripts. And again, like a good example of a script is something like a proven transfer from. So I can design a transaction where I can say, hey, I want to like approve and transfer this token into this specific contract. And you could do that in one transaction at the native level. So you don't need to have like an approved transaction and then like a transfer transaction, like all these different transactions. You can just do it all in one transaction. And similarly, again, with input coins and predicates, we've actually learned ways to build applications where you can build almost any kind of application with just coins and just predicates. And you don't need even contracts or scripts. You can just use inputs and coins and predicates. And when you have that, it means you're getting to the maximum amount of scalability possible that you can theoretically produce for a blockchain, really, in terms of how you're constructing an open system. So similarly, with predicates, with scripts, and with smart contracts, we have a virtual machine, and that's going to process the way that everything works inside of these different systems. So Fuel has its own virtual machine called the Fuel VM. We don't call it the FVM because FVM, unfortunately, was taken by Filecoin, which I don't really know who uses Filecoin. I like some of their team a lot, but I don't really know who uses it. But the point is, we'll just call Fuel VM. And then some notable architectural points are that it's a 64-bit VM, so 64-bit word size. The instructions are 32-bit. So we pack instructions into a 32-bit instruction. It has a single memory range. So if you're in any smart contract, you can actually read the memory of what was done before. So effectively, if your script calls 5 different contracts, one after the other, each of those contracts can go back and they can read previous things that were done in memory. And this reduces the amount of overhead that you have for basically cross contract communication. So in the EVM, when you make a call, you have to reserialize all the data, and then you have to copy that and move it over. So it turns out, even with the Fuel VM, we do some reserialization. However, because we can, with calls, reference backward previous information, you can leverage that to your advantage. You could say, if I call one contract, it produces a list of like 40,000 items. and then I call another contract, it can now just read any one of those 40,000 items, and it doesn't need to like reserialize all that data and just to move it over to another contract. And this really helps with cross-contract communication and significantly reduces the amount of computations you're going to need between contracts. So it's very, very useful to have a single memory range. But each call frame is only going to write to a specific sector of memory. So the call frames are protected sectors of memory. As well, the VM is multi-context, so it handles things like predicates, contracts, and scripts, and it can do even more context, but these are the core ones. We have a stack and heap model, and as well we have things like safe math by default. We also have things like error registers, and just a lot of really useful stuff that is done within the virtual machine itself. In terms of instructions, we have all the typical math instructions you would see. We also include things like big number instructions for 128 and 256-bit math. Hashing right now is just keycache 256 and SHA-256, although I think we'll integrate Blake 3 as well. Signature verification, ED25519, SEPC256K1, SEPC256R1, so Ethereum standard signing and keys, Cosmos. We're going to open up the signature verification for Solana as well. And then as well the passkey support, which typically uses R1. Memory instructions, so we have things like all your standard memory instructions, but we also have things like a dynamic memory clear, memory copy, pushing and popping over a stack, so just really useful codes there. For control, we have all your standards that are like jumping and branching operations. For blockchain, things like logging, calling, minting, burning new coins. So that's all that native asset infrastructure. So it's a fully fledged virtual machine. And again, unlike other virtual machines, either that are arbitrary like WASM or RISC-V, or that are blockchain oriented like EVM, Move, or Solana VM, the Fuel VM takes into consideration a lot of different factors, both from safety, execution, gas metering, state, and context, and just kind of how everything's holistically designed to give you a virtual machine that again is very, very powerful, but also really optimizes ideally for all the right things that you want in a blockchain virtual machine. So we also have our own language called Sway, and this is what Sway looks like. So this is like a basic counter contract. So Sway looks very familiar to something like Rust, but we brought in a lot of the paradigms that we saw from Rust, and we also brought in a lot of the paradigms from Solidity that we liked, and tried to bring it into a single system that felt the most right to us in terms of how blockchain language should feel. And I say blockchain language because I don't just mean a smart contract language. Remember, Sway is used not only to develop smart contracts, but also scripts, predicates, and other things. So it's even beyond just smart contracts. It's really a sophisticated language for a lot of different things. And as you can see here, things like notating the ABI are separated out in a macro-like setting. Things like storage are also separated out and clearly defined in a macro-like setting. These can also be imported as interfaces for different contracts. And as well, we'll also eventually support namespacing for storage, so that's going to be really handy. And then similarly with implementing your contract, you can see that we define sort of what we're touching in terms of state, so it's read and write. And we also have clearly defined storage manipulation and reading, and as well Rust-like syntax for returning and defining methods. And similarly with producing, say, like these getters. So again, it's for a Solidity dev, it probably wouldn't take very long to learn this, maybe a day or two. For Rust dev, it should feel very at home, but integrate a lot of the nice things from Solidity. So really, we're trying to bring the best of all these different worlds together and trying to bring you something that is a really comprehensive and flexible language that, as blockchains become more interesting, more sophisticated, as machine learning becomes more interesting and sophisticated, we have this single language to give you that it just answers all your questions. It answers how you build everything from contract scripts and predicates to deployment, indexing, testing, to as well things like maybe even formal verification, machine learning, and other bits and pieces that might be very valuable. Not too bullish on formal verification, but I am getting more bullish on local machine learning being integrated into these languages and kind of getting you further ahead in terms of what you need to do for your development. So in terms of the network for Fuel itself, so we're launching a rollup very soon on Ethereum, which is a full, pure optimistic rollup on Ethereum, full fraud proofs as well. It'll use 4844 blob data. The aim is for it to inherit the security of Ethereum. And the launch target is currently end Q3 of 2024, so hopefully we get there. And this we're calling the Ignition Network. That's its current working title. And you can think of the Fuel Network as just the network of all the Fuel rollups that may eventually exist over time. So this is just like a little bit about the network itself. So this will be again, a rollup that's deployed to Ethereum like a layer 2. You'll be able to bridge assets over to it. You'll be able to use MetaMask and all these other wallets with it. But it's going to be using all this new tech under the hood that gives you really incredible performance, really incredible properties of sustainability, really incredible properties of interoperability, and kind of brings to the table, again, all these features that I think blockchains really need if you want to succeed as an application in this space. As well, we just dropped our points program. So this is for bolstering new application design and ecosystem development. And the idea is that, again, people will be taking their, say, staked ETH, like any variety of staked ETH or any variety of like staked USDC, things like that. They can put it in a contract. They can withdraw it anytime. So we're not holding it like Blast or all that stuff. And then they earn points. And again, the main thing is that Fuel as a project, like I don't care about TVL for Fuel itself. I'm indifferent to that. We need to grow over time. We've got a lot of stuff to prove to the ecosystem, to everybody else. It's not really an issue for me. However, if you're a project and you're deploying on Fuel and you're trying to say, hey, like who's around, what capital's around to LP into my project, to LP into this new app that I'm building. If I don't have a good answer for you as Fuel, then we've got ourselves a big problem, right? So we did the points program not for us, but we did the points program for our ecosystem projects. And really, I think that this is something that's really, really important because obviously we all know tech is one of the most important things about the entire space, and software is incredibly important. But as we also know, liquidity, TVL, these other things are incredibly important metrics. So we wanted to make sure that we had some of that in place so that projects, when they're actually building and designing, they know, okay, hey, at least there's a certain amount of TVL available that can come and LP into my project or into my pool or into my DEX or into my order book, et cetera. Interested liquidity that wants to come here. So that was the point of the points program. Right now, we're at about 90 million TVL, which is awesome. And we only expect that to grow over time as more people learn about and find out about Fuel. So yeah, definitely check out our points program. And happy to stake there as well if it makes sense. So some last points here. So right now we're making everything available at docs.fuel the network for documentation. So this is going to be a single docs hub, and I'll walk you through the docs hub just after this presentation. As well, we're really active on our forum. So forum.fuel.network is like a really important place. And then on GitHub, one thing that you'll note, we're rebuilding this repo right now, but the Sway applications repo, it's very messy right now, but this will be the place that you're going to go for really all the different applications that you want to build that are fully fledged, fully tested applications, full front ends, full back ends. Everything's there, how it works, connectors, like the whole stack. So that's on the example side. And I can also walk you through just a few other kind of bits and pieces here. So, basically, I'll just switch over to Sway Playground. So I think you guys can see my screen, right, in terms of just my browser?
Yeah, we can.
Great. Okay. So basically, in terms of Sway Playgrounds, this is sway-playground.org. The main thing here is that this is a place you can go in the browser just to try to fool around with Sway. So we've got some examples here. Here's a counter example. Here's like a single sort of ERC20 equivalent example, right? Like a single token. So you can see how that's constructed here with minting and burning. One notable thing, again, you're not managing the balances of these tokens. You're just minting them and burning them. When you mint them, you're creating new UTXOs and they go right to the user. So this is like a kind of a crazy thing here where you're not really thinking so much about holding balances within smart contracts because that would be highly stateful. we try to create the assets and burn them, mint them right to the user. And again, that's part of our whole mentality around Fuel itself. So some notable points here. And you'll also see some other things that are probably very familiar to you, like, decimals, names, symbols. So we have a standard for that as well. Like here's, storage, what it's keeping track of, like an owner and some other things. And then as well, we also have like a multi-asset example. So this is like an EIP 1155 example. So similarly, creating multiple kinds of tokens at a single contract. So you could have a single contract that produces not only one coin, but could produce many different colors of coins. And that's useful for things like NFTs, right? You get one contract produces all different kinds of NFTs, or a contract that produces NFTs and fungibles, or whatever configuration you want. And so we have the same SOC20 standard works for that as well. And you can see here that we're actually using the standards in the language directly. So I highly encourage you to check out Sway-Playground. It's an awesome tool. One other cool thing, we do have full Solidity transpilation. So for certain applications here, we can do full Solidity to Sway if you just want to kind of do what's familiar and sort of see how that looks like in Sway itself. I'll mention that, it doesn't do every single thing, but it's hopefully useful just to give you like a sense about, hey, this is what it looks like in Solidity. This is what it looks like in Sway. So you can use it as a learning tool, but it's an awesome learning tool because you can just go from Solidity to Sway really quickly. You can kind of see how things sort of work. So that's on Sway-Playground. If we go over to the docs, so just to give you an idea of how our docs works, this is docs.fuel.network. So we have our intro section. We have a quick start here. We are going to upgrade this quick start, make it more interesting. Right now, just as a counterexample, is also running a node here. But we're going to make this a lot more interesting. We'll probably do making a token or something else. You'll see on the top right-hand side, we have testnet or nightly. So nightly being the most up-to-date. A link to our forum. Our search is pretty rich, so you can kind of search anything across the different docs. We're constantly trying to improve these docs. So I just have the DevRel team continually trying to improve examples, docs, and other things. We will get there. And what our aim is to have just the best docs in the whole space. So we're going to spend most of our DevRel resources not making stupid videos or other things. We're going to actually spend most of our time in the docs and the examples, getting everything to work well. So if you're learning Sway for the first time, you'll see here there's the full Sway book. So this is like, really comprehensive book, right, about Sway itself. If you want to learn Sway quickly, though, just pop over to Sway by example, and it's similar to Solidity by example. And you can see right here all the different sort of like, okay, how do functions work? Okay, here's how they work. How do configurable constants work? Okay, here's how they work. So you can kind of just like get to the meat of things really quickly. So you don't need to like waste too much time. We'll continue to add more examples here. So if you want to go really quickly, this is like a useful tool. There's also like a Solidity to Sway guide here, so you can just see some things. This is how you do a timestamp. This is how you do a message sender, like restriction for access control. This is how you do using U128, etc. So so we have that. You also have the books for the SDKs here, TypeScript SDK and Rust SDK. We'll eventually get rid of this wallet SDK book. That'll be merged into TypeScript SDK eventually. We do have a GraphQL API and playground that you can play around with. This is typically what people are using right now to build the bulk of their applications. Eventually, with Fuel, we do want to kill GraphQL. We want to kill the RPC, and we want to bring everything into a more real-time setting. But right now, GraphQL is still the best in terms of just using everything, loading your balances, calling contracts, these kinds of things. So that's the API we have available. So you have docs for that. You have docs for the tool chain, and then as well, you have docs for our specifications. So if you're more of a research type, you can go right into a lot of our specifications for the transaction model, the virtual machine. Some of these things still need to be updated. There's a little bit of stuff here to be updated, as well our ABI format and more specifications around our networks. But yeah, this is sort of what we have in our existing specs. Some useful links here. Again, Sway by example book. So you can go right to that. The example applications, our faucets, the standard library and core library. These are important links here. So we have them hosted here in a separate field in GitHub. And basically the idea is to try to get you as productive as we can, as quickly as we can. We also post the Sway standards for tokens and other things, and as well some useful libraries, like for example, preventing reentrancy here. We have this nice reentrancy guard. So things like that, very kind of pertinent. So the main thing is we will try to get fully functioning examples for NFTs, AMMs, order books, all this kind of stuff, so that you can go to an examples repo and have all of that in one place. We're still building that on the DevRel side, but we should have that soon. This is the points program here. So what it looks like currently. So definitely check that out. To give you an idea of what some of these examples will look like. So here's like an NFT kind of marketplace. And as you can see, lots of different connection options, both between Ethereum wallets, Fuel wallets, even burner wallets. So you can just kind of have something that runs like right in the browser itself. I don't know why that's not working. Let's see. Let's try this again. Maybe it's a Chrome thing. Here, we got to fix that. Live demo, hooray. So, so here we have like just, kind of basic burner wallet setup, and as well, like this is the way that the faucet looks like. If you iframe it into your application, you might need to do a bunch of these. So just to give you a sense of kind of what everything feels like in terms of the faucet. I don't know how many motorcycles I'm going to have to do here to get past this. Let's see. Oh God, fire hydrant. Okay. All right, we got it. So click this. Great. Okay, so now we have some ETH, and then we can go over to Explore. We could go over to some of these apps. And anyway, so we'll have full examples working for everything. We'll try to get these very clean, very nice, and you'll be able to just copy and paste them and start working as fast as you can. Our forum is very active, so we try to keep everything up to date. We try to stay on top of everything. We try to answer within a few hours, hopefully, of each question. So we try to be as helpful as we can here. And then as far as ecosystems concerned, there's a lot of different projects building on us. Some Fuel native wallets like Fuelet, Baco Safe is another one. As well, we have like an NFT project called Thunder. And then Composability Labs is one of our main builders. They're building things like order books, lending systems, AMMs. So everyone's kind of building different things right now. But yeah, we'll kind of have the makings of a growing small ecosystem right now. And yeah, I would say that's sort of the TLDR for everything. So I don't know how much time we have left, but yeah, that's kind of the presentation.
Yeah, cool. Thanks. We have like 10-ish minutes, so I think we can go through a couple of questions which have piled up in the chat and the questions tab. So Amir is asking, do testnet tokens have any kind of reward?
Yeah, so we'll clarify this in our points program AMA. So the testnet, we did mention that it is an incentivized testnet. We'll specify the exact details of what that is and what that means after that AMA. So I'll just not repeat any information. We'll just release it there. But it is to say that it is incentivized. There's going to be certain activities that will fulfill that criteria. We'll specify that in that community AMA that we're doing on the 18th. So that's the answer I can give right now.
Yeah, cool. Beccord is asking, when you say you can open up signature validation for Solana, are you referring to the native account abstraction side of things?
Yeah, so the idea is that I could open up a Fuel app, connect with Phantom or some other Solana wallet, and then just use the app. So yes, that's what I'm referring to. So it's like you can just use the raw signing in these Solana wallets and actually sign transactions directly. So the idea is you build an app in blockchain. You don't want your users to have to use some specific Fuel wallet or something else. You want them to be able to use MetaMask or Rainbow or Phantom or some whatever wallet that they have, or things like WebAuth and passkeys, stuff directly in the browser. You don't want the wallet signing to be a friction. So that's what we want to support with Solana signing. Yeah. Oh, sorry, did I disconnect here? Sorry, I'm not hearing you.
No, sorry, I was mute. It's
okay,
my
got
fault. Apologies.
Got it.
No, also from Amir, how can Fuel guarantee smart contract security?
Yeah, so I would say this, that we're constantly improving the compiler, the way that the the virtual machine and the compiler work together. As well, we're increasing our auditing surface. So, we're doing regular attackathons, regular bug bounties. And as well, we're trying to ensure that basically our system is as locked down as we can get it right now, given that it's all a new code base. In terms of contract security, if you're writing a Turing complete program at all, there's always a chance you're going to write bugs. And even if you write formal verification for it, that only means that it's going to execute correctly, not that there isn't bugs. So it's very hard to, in programming in general, just write something without bugs. So there's a lot of tools that you can provide, like, again, more unit testing, frameworks, buzzing frameworks, static analysis. We do have a static analysis tool that was built. So I can drop the link for that. So you should have a lot of different tools to help make your applications better. What I'll say is that as we move towards developing what we call like the fuel way, so getting off of smart contracts, let's kill smart contracts, let's kill the RPC, let's kill these other things. Let's move to a better, more interesting paradigm of building applications, like using conditions, native assets. When you move to that framework, there's a lot less stuff that can happen. And what's interesting about it is just you reduce the edge cases significantly because you design from a like conditional standpoint than designing from like a smart contract standpoint. And so I'll just say that as you build applications more towards sort of what we call like the fuel way, built using native assets and predicates and not smart contracts, then I think I can guarantee a lot more safety for your application because it's a lot simpler. Like predicates don't have call frames and call frame stacks and these other things. They're just these simple sort of execution conditionals. And that's what we want to aim developers to do, is to make them build simpler designs. And the simpler you can get it, the safer it's going to be. So so that might answer maybe some of the question as well. Yeah.
Yeah, thank you. How can we do account impersonation using Rust SDK like we can do it in Hardhat?
Yeah, so in terms of managing and using accounts in your testing system, that should all be done by the TypeScript SDK we have, a Rust SDK. So I'd recommend you just test that out. And in terms of tooling and in terms of other things, again, everything right now with Fuel is like eating glass. So you're walking into, it's a hard road to build on Fuel. So right now, like if you're building on it, it's not the easiest. It'll be on a trajectory where eventually in Fuel, everything will be much better than how it is in every other ecosystem, eventually. But right now, it's tough. So not everything's available. You have to get a little creative. But if you want to simulate or emulate certain accounts, that I would do through the SDKs. They should all have different features to help you emulate and use different accounts, different owners. So.
Yeah, that's a very good answer. Because again, is asking, why did you say that you can write almost any kind of a program? Does it have to do anything with tooling completeness?
So predicates in and of themselves, if we're talking about almost any program, so smart contracts in Fuel run very similar to Ethereum smart contracts. So in a sense, it's very much the same. You have things like storage, you have things like calling methods and contracts. So all of that's very, very similar. In terms of predicates don't have any state. In fact, predicates don't have anything other than just the code that they're executing. And predicates can view the transaction data that they're executing over. So they can read the code of not only their predicate, but they can read the code of all the other predicates in a transaction. They can also see what inputs and outputs there are, what scripts, like they can see all the information, the data and memory, and that's all you get. And so with predicates, they're very limited in the sense of like what they have access to, because there are these more simple primitives. But because of that, it also means that if you think about it, if you're validating or verifying it, it means I can take all the predicates and all the transactions out, and I could just verify them all in different orders at different times, because all predicates need to return true in order to be valid, in order for that transaction to be included in a Fuel block. So this means that you get like this incredible parallelization property. And not only is this something similar to what you see with machine learning and how you want to optimize something like machine learning, it's similar for blockchain. You want to actually make your program simpler so that you can optimize over it. And this is what Fuel is trying to excel at, is to try to give the developers many other ways than just smart contracts, right? These Turing complete, complex, stateful mechanisms let's try to build things that are state minimized, that are simple, that are ephemeral, that just get pruned, that come over bandwidth, that can be validated in different ways at any time. That way we can simplify the processing significantly, and you can build a lot more scalable applications. And so you have to be really clever as to how you use predicates and native assets. But we found ways to build everything from a Uniswap, lending systems, all with just native assets and predicates and the transaction model, and that's it. And no smart contracts. So it's pretty crazy what you can actually do with them if you're clever. Yeah.
Yeah, cool. This is a very broad question, but maybe we can cover it in a couple of brief points. How are Fuel and Fuel VM different from stuff like WASM or RISC-V or Move or SVM?
Yeah, so maybe the simple way to break that down is to say that WASM was designed to execute arbitrary code in the browser. It was not designed as a blockchain virtual machine. RISC-V is designed as an ISA for CPUs. It is not designed for a blockchain. It's not designed for even running as a virtual machine, but it can be. But it's very different. So those are what you call arbitrary execution environments. And then Move VM, Solana VM, and EVM are virtual machines that are designed for blockchains. But the big difference is that, again, all of those VMs are very stateful in the way that they process. They incur a lot of state. They incur a lot of processing overhead. And as well, that they are not really designed for, again, the kind of parallel processing, the kind of performance execution that we want to actually accomplish with a very high performance VM. So the strange thing to say is that Solana VM might be very low level, but the Fuel VM, if it's optimized, will probably be much faster because we can get ahead of processing in a way that they can't, because we're trying to give the developers many other ways to build programs than just smart contracts. And in that, we've reduced that complexity, which we can then increase the performance. So the Fuel VM is trying to do a lot of things at once to try to give the developer this sort of incredible environment to produce applications and blockchains that you just don't see in the space. And that's because we were able to learn from all these architectures before we built the Fuel VM. So Solana VM and Move VM are all layer 1 architectures, and the EVM being an Ethereum architecture, right? So we were able to learn all these things from all different kinds of VMs before we designed the Fuel VM.
Awesome. Moving on very quickly, the predicates are off-chain, right? So it is possible to invoke an external API before executing something on-chain.
So predicates are on-chain. They have to be posted on-chain. The code has to be posted on-chain. You have to execute it on-chain. So I wouldn't say that the predicates are off-chain. I would say that the predicates are included in transactions. They're just ephemeral. So once the full node processes them, the full node can just get rid of them from processing. If there's a set of repeating predicates where you don't want to send the predicate information over the wire every single time, then the node can decide to keep some of it in a loaded set of memory or database and then receive it over the wire with a pointer or something like that. We'll have a system for that as well. But the idea is that the full node makes no commitment to store any of this stuff. So to say it's off-chain is not necessarily correct, but I would say that predicates are these really simple programs. And if you could design your program and application with them, it's going to be way more scalable. If you can't, we understand, just use smart contracts, okay. But if you could get it into a predicate and you could build your app with native assets, it's sort of like the greatest gas golfing in human history for a blockchain application. So you kind of want to do it if you can do it. And it's really fun. It's just right now in Fuel, it's really hard and really painful to do this. We're going to try to make it a lot easier. But that's just maybe some background for predicates. So they are on-chain. They have to be posted on-chain. They have to be executed and they have to be verified. But they're just not something that we need to store. And they're also something that's very ephemeral in the way that they work. And they're stateless, which is really important. So hopefully that gives some context there.
Yeah, that I think pretty much brings us to the end because we are out of time. But very quickly, any final words, Nick? And if people have questions, where can they reach out to?
Yeah, so I'd like to just take the moment to say, I'm trying to convince you guys not to use Fuel. I don't want you to use this. If you want something simple and you want to just do what everyone else is doing, and you want to just do an EVM application, and you want it to be easy, then don't use this stuff. You can use something else. But if you want to actually design an application that will become very scalable that actually will work in a very different way, in a very sustainable way, right? Where if you were to expose it to the world, we could actually figure out ways to optimize it and scale it to the entire planet. Then you want to consider using this stuff. Right now, it's still very eating glass, but it's a lot of fun. It's very exciting because we have an architecture that was built for doing the thing that it was built for. And even though it's a little painful to get that started, it's still really far more fulfilling, I would say, if you can actually get it to all work. So, so my final words is that yeah, Fuel right now at least is not for the faint of heart. It's not for just like the copy and pasting kind of situation. We'll get it to something like that for certain people, for sure. But I would just say that if you want to improve your knowledge of blockchain, your knowledge of blockchain processing, the way that virtual machines work, the way that smart contracts work, the way that you can build different styles of applications, trying to push the boundaries of what blockchains can do, then maybe Fuel is something you want to interest yourself in and actually use. So that would be my final words to the devs. Yeah.
Yeah, that's a very, very honest answer, a very wise answer as well. Thank you very much once again, Nick. It was a terrific session, a bunch of very clear and concise information, but also in depth in certain ways as well. To everybody else, thank you very much for coming. See you tomorrow for the next session on Fuel Native NFTs at the same time as today. Until then, have a lovely rest of your day and see you later.
Awesome. Thanks, everybody.
Bye-bye.